Class, in this session we are going to continue exercise 20.2, and in the last class we had done the question number 4. In today's class we are going to start from question number 5. Alright, I hope that all of you remember that how to solve this type of questions. So we are going to start from part B. It says that integral of 1 to 2t square plus 1 divided by t square dt, right? The first thing that changes here, that instead of x, now the variable we are using is t, but it does not affect anything related to the concept or the method we are doing to solve integration. So firstly I will do the separation of LCM. So it will be 2t square over t square plus 1 over t square and dt, and the sign of integration as it is. Alright, that is the separation of LCM, and now I'm going to simplify. So t square and t square cancels, so it's 2 plus this t square when shift in the numerator at t power minus 2. Alright, dt, and the integration limits are 1 to 2. Now the function is ready to integrate, so the integral of 2, it will be 2t plus integral of t minus 2, it's t minus 1 divided by minus 1, and the limits are 1 till 2. Alright, so if we are going to apply the upper limit, so it's 2, instead of t it's 2 plus minus minus t is 2 to the power minus 1. That is my upper limit, minus lower limit, it's 2 minus 1. Alright, 2 2s are 4, 4 minus 2 power minus 1, it's 1 upon 2, minus 2 minus 1, it's 1. So 4 minus 1 upon 2, 1 upon 2 is 0.5, right? So 4 minus 0.5, it's 3.5 minus 1, that is equals to 2.5, and that is your answer. So first you need to note down the solution in your copy, and for that part you have a time of 40 seconds, so start. Alright, after part B, moving towards the next one, it's part D. Question is integral of 2 to 3 r minus 1 r plus 1 divided by r square dr, right? So first you need to try it by yourself, and time for this part is 2 minutes, so start. Alright, so firstly we need to apply the identity here as well. A minus b, a plus b, it will be a square minus b square, or you can simply multiply, it will be same, divided by r square, integration is 2 to 3 and dr. Now we need to apply separation of LCM, so I can say that it's r square divided by r square minus 1 divided by r square, again dr, and integration is 2 to 1. Now we can simplify, so it's 1 minus r to the power minus 1 upon 2, integral of 2 to 3, and it's dr, right? Now the function is ready to integrate. The integral of 1 is r minus r to the power minus 1 divided by minus 1, and limits we have, it's from 2 to 3. So I am placing the upper limit here, so it will be 3 minus minus plus 3 to the power minus 1. That is my upper limit, minus lower limit is what? 2 plus 2 to the power minus 1. So 3 plus 1 upon 3 minus 2 plus minus plus minus 1 upon 2. 3 minus 2 is 1 plus 1 upon 3 minus 1 upon 2. LCM is 6. 6 plus 3 2s are 6, 2 1s are 2, 2 3s are 6. So 6 plus 2, 8, 8 minus 3, it's 5 divided by 6. So that is your final answer. Alright, so I hope that all of you clear the steps, the methods we are using to solve the definite integrals, and make sure that before start integration like I'm doing in these steps, first I am simplifying it before integration. Alright, so simplification is very important. If you are doing it, then it will make your question a lot easier. Alright class, so moving on towards the next question. It's question number 6. It says that find the value of the constant k if integral of 1 to 2 of the function 4x plus k dx is equals to 1. Alright, so we have a function 4x plus k. Alright, firstly we need to integrate that function, and the integrated part is equals to 1, and then we will have an equation which we need to solve to find the value of k. So firstly we need to integrate it. So first I will separate the sign of integration. So it's 4x 4 integral of 1 to 2 x dx plus integral of 1 to 2 k dx, right? The integral of x, it will be x square divided by 2, and the limits is 1 to, plus integral of constant, it's x, limits are 1 to 2. Alright, and I need to apply the limits first. So 2 2s are 4, so it's 2, upper limit is 2, so 2 square is 4, minus lower limit is 1, so 1 square is 1. Similarly k, upper limit is 2 and lower limit is 1, so it's 2, 4 minus 1 3, plus k, 2 minus 1 is 1, so it's 6 plus k. Alright, and now this part, the integrated part, is equals to 1, and we need to apply the same, that integrated part is equals to 1. So we have 6 plus k is equals to 1, implies that k equals to -5, and that is your answer. Alright, so that is an introduction regarding the word problems, you can say that. Alright, so you need to understand the condition very carefully, that what you need to exactly to do in this question to find the unknown. Alright, and in this question it says the integrated part is equals to 1, that is why we first integrate the function and then equate it to 1 to find the value of k. So you need to write down the solution in your copy, and for this part you have a time of 40 seconds, so start. Alright, I hope that all of you are clear now. Moving towards the next question, that is question number 7. Alright, given that d by dx of f of x is equals to under root x minus 1, evaluate f of 4 minus f of 1. Alright, first we need to understand the question, that what is given. It's given that d by dx of f, and what is asked, it's asked f of 4. That means I need to eliminate the sign of d by dx, and for this part d by dx of f of x is equals to under root x minus 1, right? We need to eliminate the sign of differentiation here, and the reciprocal function of differentiation is integration, so I need to apply integrate on both sides. Alright, so this part here cancels the effect of d by dx, so I have left with f of x only, which we are looking for, is equals to, when you integrate this function, so under root x is basically x to the power 1 upon 2, right? And when we add 1 in the power, so 1 upon 2 plus 1, it's 3 upon 2. So that is equals to x to the power 3 upon 2 minus 1 integral is x. So that is f of x is equals to x 3 over 2 minus x, means half of the question has been done. Now we need to find f of 4, and then we need to find f of 1. Is basically the same concept of limits, the way to present it is a slightly different. So now we need to find f of 4. You can say that that is my upper limit. So instead of x we need to write 4 minus 2 and 4. So 4 to the power 3 upon 2. 4 to the power 3 upon 2. 4 is what? 4 is 2 power 2 and whole power 3 upon 2. 2 and 2 cancel. 2 cube is 8. So 4 to the power 3 upon 2, it's 8 minus 4, that is left over with 4. So you got your first answer, that is f of 4. After that we need to find out f of 1. So f of 1, again in this same equation, it will be 1 minus 1 leads to 0. So finally f of 4 minus f of 1, that is given in the question. So f of 4 is 4 and f of 1 is 0. So the final answer we have, it's 4. And I made one mistake here, and the mistake is what? I forgot to divide it with the total power, that is 3 upon 2. Alright, so the function will be little bit changed, and I need to solve it. So make sure that you are not doing any mistake. Alright, so now f of x is equals to 2 upon 3 x to the power 3 upon 2 minus x, right? That is my function. Now I need to find the value of f of 4, so that will be 2 upon 3, 4 to the power 3 upon 2 minus 4. 4 to the power 3 upon 2, it's 8. We had done it already, so 2 upon 3, it's 8 minus 4 leads to 16 upon 3 minus 4. If you take LCM, that is 3, it's 16 minus 12 leads to 4 divided by 3. Now that is the value of f of 4, and now we need to find f of 1. So f of 1 is 2 upon 3 times 1 minus 1, right? So it will be 2 upon 3 minus 1, again LCM 2 minus 3, it's minus 1 upon 3. Now in question it says to find f of 4 minus f of 1. The value of f of 4 we got, it's 4 over 3 minus f of 1, it's minus 1 over 3. The 4 plus 1 leads to 5 over 3. Alright, and that is your final answer, 5 over 3. So you need to write down the solution in your copy, and you have a time of 60 seconds to write it down. So start. Alright, after question number 7, moving on to the next one. It's question number 8. Alright, it says that given that d by over dx vx is equals to pi x square, evaluate v of 3 minus v of 1. So we need to have a function v, but currently we have d by dx of v. Alright, so we know very well that first we need to eliminate this function of differentiation, that after that we will have only v of x, right? The same approach we have attempted in last question, but this question you need to do it by yourself, and for this complete question you have a time of 4 minutes, right? First we need to eliminate the sign of differentiation, then you have a function of v. Alright, or you can say that in first step you need to integrate your function, after that you need to place the value of v3 and then place the value of v1, and you will get your final answer. So first give it a try, time is 4 minutes, start. Alright, so the function we have, it's d by dx of v of x is equals to pi x square. You can say that it's d of vx is equals to pi x square dx. We need to apply the sign of integration on both sides. So now on the left side is cancelled, so the leftover part is v of x, which we were looking for, is equals to pi outside the integral sign because it's a constant, and the integral of x square, it will be x cubed divided by 3. Alright, since there is no sign of nothing. So now you have v of x, right? Now we need to find the value of v of 3 and v of 1. So v of 3, it will be pi, instead of x it's 3 cubed divided by 3, so that will be 3 square 9, so it's 9 pi, that is v of 3. Similarly, if we need to find v of 1, so that will be pi over 3. In question it says v of 3 minus v of 1. So v of 3 is what? V of 3 is 9 pi minus v of 1 is what? It's pi over 3. Taking LCM, it's 3 9s are 27 pi minus pi, and it's equals to 26 pi over 3. Alright, so that is your final answer, 26 pi over 3. So keep in mind that when dy dx is given and you need to find out the function only, so you need to apply the sign of integration on both sides, because integration and differentiation are reciprocal functions. Alright, now before proceeding to the next question, let me give you some example, because that is quite important for your upcoming question. So it's example number 12 from your book. It says that given that integral of 1 to 3 f of x dx is equals to 3. Alright, for first part it says to find the value of integral of 3 to 1 f of x dx. Now if you do remember that I told you three important principles for the definite integrals. If we have the value of 1 3 and it asks the value of 3 1, what is the property we had discussed in the last class? If you do remember, that is good, but if you can't remember, observe here. If you have a to b f of x dx, so that is equals to negative sign of b to a f of x dx. Alright, that we had already discussed in last class. If it's a to b and now we are doing b to a, so we need to change its sign. The same thing we need to apply in this question. 1 to 3 limit is given and it asks 3 to 1. Alright, so if 1 to 3 it's positive 3, then 3 to 1 it will be negative 3. That is your first part answer. Alright, for part B, it says integral of 1 to 4 f of x dx. Alright, f of x dx from 1 to 4. So in your question you have from 1 to 3 it's 3 and 3 to 4 it's 2. So if you need to go from 1 to 4, you can say that first I will travel from 1 to 3 f of x dx, and then from 3 to 4 f of x dx. So ultimately we had reached from 1 to 4, that is basically asked in the question. So integral of 1 to 3 f of x dx is 3 plus integral of 3 to 4 f of x dx is 2. So the answer is 5. Alright, so I hope that these two parts are clear, and for the last part it says integral of 1 to 3 f of x dx plus integral of 4 to 3 f of x dx. So if you observed in the last question, keep in mind that the end point of first limit and the starting point of second limit, they should be same. Alright, so with the same approach, why don't you give it a try first? And for that part you have a time of 90 seconds, so start. Alright, so if you observe that the trailing end here is 3, but the starting point here is 4, so you cannot add these two limits here. So first we need to change the sign, so it's integral of 1 to 3 f of x dx. Now we need to apply the property here which we used in the first part, so it's minus 3 to 4 f of x dx. Now 1 to 3 f of dx is 3 minus 2, that is equals to 1. Alright, so there is one more similar question like this one. It says that integral of 1 to 3 f of x dx equals to 3. You need to find integral of 1 to 3 2 f of x dx. So that is very simple. If f of x dx equals to 3, then 2 f of x dx, it will be equals to 6. So whenever you are solving such type of questions, what you need to observe the most is the limits number. Alright, since we have 1 to 3 here, we have 1 to 3 here, that means the answer will be 3. But if the limits are not same, then you need to solve the limits first before giving your final answer. Alright, so up till now what we had discussed regarding the topic integration, that what are indefinite integrals, what are definite integrals, right? The main difference between these two, in indefinite integral we need to introduce the constant c in your answer, but in definite integrals we don't need a constant c because we have specified limits. The important principle to integrate any function is its derivative part should be present at next to it. If the derivative is present, then you can easily integrate the function. And by integration I mean that you can easily add 1 into the power and then divide it by total power. If I give you an example, let's suppose we have 4x plus 3 power cube dx and we need to integrate that function. Now before starting the integration, we need to ask a question from ourselves that what is the differentiation of 4x plus 3. So if you find the differentiation of 4x plus 3, that will be equals to 4. So you need a number 4 present here. Is it present? No. So what you will do, you can multiply and divide by the constant 4 so that the derivative part is present with your integrated question. Alright, and now the differentiation of this question is present here. Now the function is ready to integrate. That means now we can add 1 in the power, so that will be 4 divided by total power, and that 4 is basically here. So the final answer is 4x plus 3 divided by 16 whole power 4, and since it is an indefinite integral, so you need to introduce your constant c. Alright, so this principle or this rule will be very beneficial for you if you learn how we are applying this principle. Then trust me, in our upcoming classes there is no need to learn any working formula while solving for sine, cos, tan or exponential function. The same principle I am going to apply in all the exercises. The main principle, the main thing is when we are going to integrate, we are going to add 1 in the power and divide it by total power. Alright, since this is the beginning of the topic integration, so make sure that you are attempting all the questions while I am giving you the time during the session, that try it by yourself. Then beta, please try all these questions because that will be beneficial for you. Alright, and if you are stuck at some point, then you can easily easily watch the solution and highlight your mistake. But with this approach, with this practice, it will be very beneficial for you. Alright, so I think that it is quite enough for today class regarding the integration portion, and in the upcoming classes that will be very important, because in the next class, hopefully inshallah, we are going to discuss that how to solve the reverse integration question. Alright, since in our integration there are no such rules like u into v and u upon v, which we had discussed in differentiation, right? So how we are going to solve such functions when they are multiplying? So for such functions, the differentiation part is always given, so you can use that part to find out the integration. And in short, what I'm saying, in the next class we are going to start the reverse integration. That is very important. But before your next class, make sure that you have a very good command regarding all the integration and differentiation session which we have discussed so far. Alright, so see you in next class, and make sure that you are going to submit your homework by yourself. No need to copy it from your friend. Try to attempt all the questions by yourself, and if you are facing any problem, don't hesitate to comment me on the portal and I will get back to you as early as possible. Alright.